Example 4. Let Sn represent the following statement. 7 times 8 plus 7 times 8 squared plus 7 times 8 cubed plus all the way to plus 7 times 8 to the nth power is equal to 8 times 8 to the nth power minus 1. Prove that Sn is true for every positive integer n. All right, so we have ourselves another case of mathematical induction. We are going to begin with the base case. So I need to verify S1, meaning I need to prove that this statement is true for n equals 1. So I'm going to write if n equals 1, then S1 becomes what? Well, go to the statement. Everywhere you see an n, replace it with 1. So on the left, I'm going to put a 1 right here. So we're starting to add terms with this guy, 7 times 8, which is to the first power, by the way. We're ending with 7 times 8 to the first power. So essentially, the only number on the left side is going to be 7 times 8. Okay. On the right side, what do you get if you plug in n equals 1? Well, you would get 8 times 8 to the first power minus 1. So we need to simplify now and see if this is a true statement. So this is going to give us 56 is equal to 8 times 7. So we get that 56 equals 56, which is a true statement. Thus, S1 is true. Okay, so we have proven the base case. We plugged in n equals 1 and showed that we get a true statement. Moving on to parts B and C. We are preparing for induction. We are going to write the statements Sk and Sk plus 1. So let's start in part B with writing Sk. Okay, so here we're going to plug in k for n, and that will give us the statement Sk. So I'm going to come back up here. Everywhere I see an n, I'm going to replace it with k. Okay, so right here, scratch out the n, put a k. So on the left side, we are going to have 7 times 8 plus 7 times 8 squared plus 7 times 8 cubed. We are adding all the way up until 7 times 8 to the k power. That has to equal, if we go back to the right side, replace n with k, it's going to be 8 times 8 to the k minus 1. All right, so that's it. We don't have anything to simplify. This is the statement you get if you replace n with k. So this is Sk. All right, we're going to do the same thing in part C to get the statement for n equals k plus 1. The only difference is we are replacing k with k plus 1 now. Okay. On the left side, we'll go ahead and write that down. We're going to have the statement S of k plus 1 is going to be 7 times 8 plus 7 times 8 squared plus 7 times 8 cubed. We're adding here all the way up until 7 times 8 to the k plus 1 power. Do remember when you're writing the statement for k plus 1, you need to make sure that the kth term appears, okay? So if this is the last term, what is going to come before it? Well, it's going to be 7 times 8 to the kth power. You need to see this term in order to use the assumption in the induction step, okay? If you're confused on this, I mean, just look at each term. You've got 8 to the first power, 8 to the second power, 8 to the third power, and so on. So the term that comes before this last one, the power on 8 has to be the k power, okay? All right, we need to write down what's going to be on the right side here. Okay, if we go back up, replace n with k plus 1 on the right side, we're going to get 8 times 8 to the k plus 1 minus 1. Okay, so it's just going to be this, whoops, 8 times 8 to the k plus 1 minus 1. Okay, so let me make sure that's right. Yes. Okay, usually we're supposed to simplify, but there's nothing we can simplify at this point. Okay, so I'm just going to move on. I have Sk plus 1. I'm ready to go to the induction step. So moving on to part D on page 10, we are ready for the induction step. So again, that means we're assuming that SK is true, and we're using algebra to change SK to SK plus 1. Okay, we always begin the induction step by assuming that SK is true. So we are going to assume that, and then we're going to go back and grab SK from part B, write the whole thing down. Okay, so we're assuming that 7 times 8 plus 7 times 8 squared plus 7 times 8 cubed plus all the way to 7 times 8 to the k power is equal to 8 times 8 to the k minus 1. We are accepting this as fact, okay? And then we're going to use this to prove the statement in part C, okay? How do we do that? Well, we go back to the statement in part C. This is what we're assuming, and this is what we have to prove. We always begin by writing down the left side. Okay, so I'm going to go back and do that. Then, okay, we're beginning our proof. Write down the left side of the equation in part C. So 7 times 8 plus 7 times 8 squared plus 7 times 8 cubed plus all the way to 7 times 8 to the kth power plus 7 times 8 to the k plus 1 power. Okay, that's the entire left side. Okay, so what we have to do at this point is not write down the right side. We have to start with this left-hand side that we just wrote down and use our assumption, and then use algebra. And the combo of the two, between the assumption and the algebra, you have to work it until you get the right side of this equation, and then we will be done. Okay, I'm going to continue on the next page. I'm going to write down my goal so that I know what I'm after. Okay, our goal, I'll put it in red. Okay, the goal is to turn this into 8 times 8 to the k plus 1 minus 1. Okay, let me just double check that. All right, that is our goal. All right, so at this point, once you write down the left side of the statement in part C, you need to apply the assumption, okay? And again, that is why you have to have the kth term right here, because it matches up with the assumption. The assumption tells us that how to compute 7 times 8 plus 7 times 8 squared plus all the way to 7 times 8 to the k power, which is this quantity. Okay, so the stuff in yellow matches, and we know by assumption that the stuff in yellow is equal to 8 times a to the k minus 1. Okay, so I'm going to write that down. The stuff that I just highlighted in yellow is the same thing as 8 times 8 to the k minus 1. Okay, so the yellow stuff matches up, but then I have a plus 7 times 8 to the k plus 1 power. Okay, we have used our assumption. So at this point, what we need to do is use algebra to turn this right side into our goal. Okay, our goal is over here in red. Okay, so this is just a reminder, when you're doing the algebra part, there's probably more than one way to do it. Okay, so you may do something completely different than what I'm about to do, but get there in a correct way. Okay, so just keep that in mind. Okay, there may not be one exact correct way to do this. My instinct here when I look at this is distribute. Okay, so I'm going to send the 8 here and here. So I'm going to get 8 times 8 to the k power minus 8 plus 7 times 8 to the k plus 1 power. Okay, when I look at this first term right here, 8 times 8 to the k power, I see a power of 8 times a power of 8. So the exponent on this first 8 is 1. When you have a power of 8 times a power of 8, you can combine them into 1 power of 8 by adding the exponents, okay? You need to go back to laws of exponents in section 4.5 if you need to, okay? Have a power of 8 times a power of 8, add the exponents, okay? Then you still have the minus 8 plus the 7 times 8 to the k plus 1, okay? At this point, I see like terms. This term has an 8 raised to the k plus 1 power, as does this term, okay? So I am going to combine these two like terms, okay? But I'm going to do a little bit of rewriting so that it's clear. This first term is 1 times 8 to the k plus 1. I'm going to write this term next so that they're side by side. We're going to have plus 7 times 8 raised to the k plus 1 power, and then we'll have the constant minus 8, okay? The first two terms have this 8 raised to the k plus 1 in common, so I'm going to factor that out, and that is going to leave me with 1 plus 7, okay? Again, you can distribute to check yourself. This is 1 times 8 raised to the k plus 1 power plus 7 times 8 raised to the k plus 1 power. And then I'm still going to have the minus 8 hanging around. 1 plus 7 is 8. That's what we're multiplying by. So this is going to be 8 times 8 raised to the k plus 1 power minus 8. Okay. And then I have another set of like terms. Okay. This first term has an 8. This term has an 8. I can factor it out. That is going to leave me with 8 raised to the k plus 1 power minus 1. And boom, that is my goal. Okay, so we are done. We took the left side of this entire equation, left side of the equation in part C. We used the assumption, we used algebra, and we got to the right side of the equation in part C. Okay, so that means we are done with the induction step. Okay, I will write my little blurb. This final result is the statement for n equals k plus 1. It has been shown that if the statement is true for n equals k, if that is true, then the statement for n equals k plus 1 is also true. Okay, we're done with the induction step. Okay, in part A, we proved the base case. In part D, we carried out the induction step. So therefore, in part E, we can conclude the 2 steps required for mathematical induction have been completed. So the statement Sn is true for every counting number n. The proof is done.